Hi friends, so let us solve one problem on arc furnace. Okay, so let us read the problem and take the required, whatever the data has been given to us. So the first one is, it is a three-phase arc furnace has to melt 10 tons of steel in 2 hours. Determine the average kilowatt input to the furnace of its overall efficiency has been given as 50%. If the current is 9000 ampere with the above kilowatt input and the resistance and reactances have been given are 0.003 ohm, 0.005 ohm. Determine arc voltage and total kilovolt ampere taken from supply. Assume latent heat of steel is 0.12, latent heat of fusion of steel is 8.89 kilocalorie per kg, and melting point of steel is 1371 degrees centigrade. Ambient temperature is 20 degrees centigrade. So what exactly happens here? So here we need to find heat energy required, and we need to equate this heat energy into electrical energy. Okay, and later we will see, after that it is electrical energy only, so from that electrical energy we will take electrical power. After that we will move on to, as per our, once we know the electrical power, then we will move on to just like Ohm's law. So we will finish it off in a very easier manner. So here what we want arc voltage and also total kilovolt ampere taken from the supply. Okay, let us see this part. First we need to identify the heat required. So to go ahead with this, first we need to find latent heat. Two heats are available here. One is latent heat required. So latent heat required is equal to latent heat of fusion of steel, latent heat of fusion of steel into weight of the weight of the material. So which will be equal to latent heat of fusion of steel is 8.89 kilocalorie per kg. So this is the latent heat per kg, but we have 10 tons. So let's move with this. It is 8.89 into 10 tons, 10 into 1000. So it, which will be equal to 8.89 into 10 to the power of 4 kilocalories. Okay, now we need to identify required heat required to raise the temperature from 1371 degrees centigrade. Okay, that's what our required melting point. From the ambient temperature is 20 degrees centigrade. That means from 20 degrees to 1371 degrees we need to heat it up. So for how much heat is required to get the temperature from 20 to 1371. So here is the formula, same thing, weight has to be there. We can write like this only. So latent heat of steel into weight of the steel into change in temperature. So it will be equal to, the latent heat is 0.12 and weight is 10 ton into change in temperature is 1371 minus 20. It is 1351. So it will be equal to 162.12 into 10 to the power of 4 kilocalorie. Okay. Now what is the total heat required? Therefore, total heat required is equal to, so sum of these two only. So all are, see they are in cm units, kilocalorie, and 10 to the power of 4 and 10 to the power of 4. So simply add them. So it will come around 171. It is almost 171 into 10 to the power of 4 kilocalorie. So this can be easily converted into 1988.3 kilowatt hour. Okay, because 1 kilocalorie is equal to 760 kilowatt hour. Since 1 kilowatt hour is equal to 860 kilocalorie. Okay, I am sorry, it is 860 kilocalorie. So with this equivalent, we have converted heat energy into electrical energy. So once it has come, it is very easy for us. Okay, but what happened here? This energy is, I mean, whatever we have done this energy is for 2 hours, not for 1 hour. So therefore energy power required is, okay, it is in kilowatt hour, so it is per 1 hour. Okay, but it has given in 2, so that's why what is power? So power required is equal to 1988.3 kilowatt hour. So this is for 2 hours, so per 1 hour it will be divided by 2, so it will be equal to around 994.15 kilowatt. But it has mentioned, that means from heat energy to electrical energy there is a efficiency. So this efficiency is 50% only. Efficiency is 50%. So with this 50 percentage of efficiency, I need to provide double the power. So actual power input should be actual power input to the furnace should be 1988.3 kilowatt only. Okay, this is the actual power. Now coming to the, this is electrical power now, so we can go ahead with the electrical terms. So now it's, our job is very simple. Now I need to write the formula for three phase electrical power, that is 3 vi cos phi, which is exactly equal to 1988.3 kilowatt. So we identified power is equal to 3 vi cos phi is equal to 1988.3 kilowatt. So let me convert into watt simply. That's all. Now I want to know about V cos phi, which is equal to, because I don't know V and I don't know cos phi, and which is equal to 1988.3 into 1000 divided by 3 into I. So what is I? Current is 9000, which has been given. So if I cut these three, it will come around 73.645. Sorry, 73.64 V. Yeah. So this is the total real power we can call. So this will be equal to, this real power will be equal to V cos phi is equal to, this is the real power, so it will be equal to arc drop, so drop in the arc plus resistive drop. So V cos phi has been given as 73.64, which is equal to, I don't know the arc drop, and this arc drop will be the voltage across the arc. Okay, plus resistive drop is V, I mean current I into R. So I has been given as 9000 ampere and R has been given as 0.003 ohm. So which will be which implies arc drop or arc voltage will be equal to 73.64 minus 27, so which is equal to 46.64 volt. So this is our first problem. Okay, arc drop is our first problem. Now we need to find out kVA. So how to find kVA? So to find out voltage, okay, this is V cos phi. Similarly, to find out, I need to find V sin phi also. So that is called as reactive drop. So what is the reactive drop? Reactive drop is equal to current I into reactance. So which is equal to I has been given as 9000 and reactance has been given as 0.005. So which will be equal to 45 volt. Now I can easily find voltage supplied is equal to square root of resistive, total, this is V cos phi square plus reactive drop. Okay, here arc is also introduced. So because of introduction of arc, the real power has to be equal to a resistive drop only, but because of introduction of arc, even arc can also produce some voltage drop. So sum of arc drop and resistive drop will come as the real drop now. Okay, that's why we have to take both the things as the real drop. So it should be equal to 73.64 whole square plus the reactive drop is 45 square. So which will be equal to 86.3 volt. 86.3 volt. So this is voltage. Now how to find input kVA? So let me write kVA input. So it is kVA input. So no need to worry about anything. Just multiply voltage and current. So what is voltage and current? It should be 3 VI because it is in 3 phase. So which is equal to 3 into 86.3 into the current is 9000 ampere. So this will come around 2330 kVA. Okay, so this is the very simple explanation of this problem. So if you still have any more doubts, you can type in the comment window so that I can answer you within 24 hours. Okay, please like this video and share this video with your friends and kindly subscribe to my YouTube channel. Thank you so much.